So good morning, one and all. Today, I'm talking about the analysis of indeterminate structures. In that, so I'm going for the third module, Carney's method. So, in the introduction, the Carney's method is the best displacement method for analyzing the indeterminate structures, particularly building frames. So it's very a good method for the building frames with sway or without sway. It was developed in Germany in the year 1947 by Dr. Gaspar Carney. So that's why the method is called the Carney's method. Like moment distribution, it is a method of solving slope deflection equations by an iterative methods. So we'll go with the iterations 1, 2, 3, 4. So that will be a procedure for that. Hence, this will fall under the category of stiffness method, wherein the level of difficulty would be decided by the degrees of freedom. The Carney's method, the entire joint moment is taken for iterative correction. We treat the iterative process as completed when we find two successive values of moments nearly equal, means in the fourth or fifth iterations. So we have to consider the iterations. In the previous iteration will be the same or nearly the final iteration. So we will consider that final contribution, the final value will be the contributional moment. So there are so many 5 steps are involved. In the step 1, again we have to determine the fixed end moments based on the external given loads. So already we have considered in the slope deflection as well as in the moment distribution also. And the first step will be determine the fixed end moments. So there are the standard equations to find out the fixed end moments for the different loading conditions, different type of the load. So if it will be a UDL, there will be one equation. For point load, one more equation. So different equations will be used. So in the second step, compute and tabulate all rotation factors for all joints that would have a rotation. The rotation factor is equal to half of distribution factor. Already you have calculated. Already you have tabulated the distribution factor in moment distribution method. So this distribution factor is the relative stiffness to the summation of the relative stiffness for the particular joint. The K is the relative stiffness, so moment of inertia to the length of the member. So finding the relative stiffness K for the different support conditions, already so you have considered how the K value will be in the moment distribution method. Now I will repeat it. So we are considering as a fixed A to B. So figure number 2, A to B, the K is equal to I by L. For KAC, 3 by 4 I by L, AD, 3 by 4 I by L, KEE, I by L, so 3 by 4 I by L, 3 by 4 I by L, and KH, 3 by 4 I by L. So important note here, for fixed end, if the AB, so check the position of B, is it fixed? Yes. If it is fixed, the K is equal to I by L. And only the two cases having the K is equal to I by L, rather than that K is equal to 3 by 4 I by L. K is equal to 3 by 4 I by L. So example A, B. So check whether the position of B is fixed. Yes, it is I by L. So consider AC. Is it fixed? No. Is it continuous? No. So it is a pin jointed. So K is equal to 3 by 4 I by L. So same as considering AD. Check the position of D. Is it fixed or continuous? No, it is a simple support. So K is equal to 3 by 4 I by L. So now considering AE, the relative stiffness of AE. Check the position of E. Is it fixed? No, it is a continuous. So if it is a continuous, K is equal to I by L. So if you are considering the fixed and continuous, then only you have to check for the simple support, roller or hinge support. You should not go with the directly A, E. The position of E is a simple support, so 3 by 4 I by L. No. So first it will be a continuous. Fixed, continuous, roller, hinge, simple. So in this sequence, so you have to calculate the K values. So if it is equal to EF, check the position of F. Is it fixed? No. Is it continuous? No. Because if one more support will be there after the F, so you have to consider there will be a continuous. Otherwise, so it will be a simple support. So K is equal to 3 by 4 I by L. So keep in mind, it's very, very important to determine the rotation factor. So same as AG, so it will be a hinge support. So you have to check the sequence. Is it fixed? No. Is it continuous? No. So it is a hinge support. So K is equal to 3 by 4 I by L. So come to the AH again. So it is not fixed and it is not continuous. So it is a roller support. The K is equal to 3 by 4 I by L. So this is very, very important to determine the rotational factor. While you are calculating the K value, just you have to calculate the K by summation of K. Then you have to calculate the rotation factor minus half into distribution factor. So while you are calculating the distribution factor in the moment distribution method, just you have to add one more column there. So that column is rotational factor is equal to minus half into distribution factor. So it will be very simple, the second step, compared while you are perfect in the moment distribution method. So it will be very simple to calculate the rotational factor. Just multiply it by half, minus of half. Then next, the step number 3. So the fixed end will not have rotation factors nor rotational contributions either to same or to the opposite end. So if in the figure also, so A, the contribution moment M dash or whatever may be the denoted. So M dash AB, so that will be 0 initial, that will be a 0. The next fourth step, extreme simply supported ends will initially get a fixed end moment as per the step 1. Compute and tabulate all rotation factors for all joints that would have a rotation. So we have to take a flow diagram for that. Already it is shown in the figure. So in the figure, so MFAB, MFBA, MFBC, MFCB. So in the box, we have two rotational factors. One is RFBA and RFBC. And at the smaller box, so we have MFIJ, summation of two fixed moments at the related joint. If we are considering the joint B, MFBA plus MFBC. So you have to add, then put it there. Rotational factor already you have calculated in the second step, so put the values. Fixed end moments already you have calculated in the first step, just put the values. So I will tell you how to solve the values by flow diagram. The step fifth step. In the first, so you have to first cycle iteration. So you have to go with the iterations. I will tell you the procedure in the problem. So you have to go the iterations as per the procedure. So you have to calculate the all iterations until the previous iteration will be the same as the final iteration. The next, so how to take the iterations? So we have an equation here. Mij is equal to rotational factor. That will be the final moment, contribution moment. Mij is equal to rotational factor of Ij, summation of Mfi means summation of moments at the particular joint plus summation M dash Ji, that will be the far end moment, far end contributional moments. So if you have confusion here, so I will solve in the example. And the final step, the final moments, MFIJ, the fixed end moment, MFIJ plus 2 into near end contribution plus far end contribution. So here I will consider a numerical problem where we have to analyze a continuous beam by Carney's method. So we have to draw shear force diagram and bending moment diagram. So we have a figure here. Support A is fixed and D is fixed, and intermediate supports are hinge supports, but that will be the continuous. B and C are the continuous one. So here we have to calculate MFAB, MFBA, BC, CB, CD and DC. So if it is a point load not at the center, so your equation, standard equation to determine the fixed moment is minus WAB square by L square. Then MFBA is plus WA square B divided by L square. Here A is 1, B is 2, L is the total span 3. So based on the equations, so we have to calculate the fixed end moments. So MFBC minus WL square by 12 and plus WL square by 12. And CD, WL by 8 and WL by 8. So based on the solution, so we have a values. So here in the step 2, so we have to determine the rotational factor. So we have to consider the joint B and intermediate supports, joint B and joint C. In the joint B, we have two members, BA and BC, and CB and CD. So important thing is the third column. So K is equal to, so how to find out BA? What is the position of A here? What is the position of A? Fixed. If it is fixed, I by L. If it is fixed, I by L. So I is 1.5I. So now come to the BC. What is the position of C here? It is a continuous. It is a continuous. So it is I by L. So there will be a correction here. I by L. That will be 2 into I divided by 4. Make the correction that 4 will be not there. 4 is not there. So it is 0.5I. So next CB, what is the position of B? It is a continuous. So 2I by 4 again 0.5 and the similarly, so we have to calculate CD. D will be the fixed. So based on that, so we have to calculate the distribution factor K by summation of K and rotation factor. Rotation factor minus half into K by summation of K. So make the correction at BC. It is I by L. It is not I by 4L. So it is I by L. So in the step 3, we have to go with the rotational contributions. So it's very, very important. So before that, you have to check. So what is the note there? MFB in the figure 1 is the summation of MFBA plus MFBC. At the joint B, so we have minus 48.8 here. So how it will be? So it is the summation of 17.77 plus minus 66.67. Addition of these two will be the MFB. And MFC is summation of 66.67 minus of 20, you will get 46.67. So you will get MFC value. So in the box, minus 48.8 and 46.67. And minus 0.25, minus 0.25, these are the rotation factors. And minus 0.33 and minus 0.167, these are the rotation factor of RBC, RCB, RCD and RBA. So here next, for the joint B, BA and BC. For joint B, M dash CB is the far end value, and joint C, M dash BC is the far end value. So what? That 12.2. So only one far end value. For the joint B, M dash CB will be the far end value, and joint C means both the members, M dash CB and M dash CD while calculating. So M dash BC is the far end value. So these are the calculations. So how it will be done? These are the iterations. So 1, 12.2, 1, 17.1, 17.51, 17.54, 17.55. So here we have go with the 5 iterations. The final iteration will be the same, nearly same to the previous equation, previous value. So how the iterations will be? So here the first iteration. So there will be equation for the joint B, M dash BA is equal to rotation factor of BA into MFB plus far end moment. So M dash BA first value, M dash AB will be the 0 because it will be a fixed support. So rotation factor of BA minus 0.25 and MFB is minus 48.8 plus 0. Initially the far end is 0. There is no any values. In the first iteration, the far end moment is 0. The next M dash BA, that will be the 12.2. And come to the M dash BC. Rotational factor of BC, MFB plus far end moment. minus 0.25 minus 48.8 plus 0. Again initially far end is 0 because m dash BA and m dash BC, m dash CB is the far end. Listen carefully, for BA and BC, m dash CB is the far end value. Initially m dash CB is a 0 value. Then next come to the joint C. The m dash CB and m dash CD we have to calculate. M dash CB is equal to rotational factor of CB into MFC plus far end moment. So rotational factor is minus 0.333 and MFC is 46.66 in the smaller box plus 12.2. So this will be the m dash BA because for the joint C, m dash BA is the far end value for CB and CD. So 12.2 is the far end value. So the value is minus 19.60. Now come to the m dash CD. Rotational factor of CD, MFC plus far end moment. So minus 0.167 into 46.66 plus 12.2. So see here, for CB and CD, only one far end value because we are considering the joint C. Joint C having only one far end moment, that will be m dash BC, because m dash DC will be the 0, so we should not consider that. M dash DC is 0, only the CB BC will be the far end value. So now we will come to the second iteration. See, in the first iteration we have to calculate the m dash BA, m dash BC, m dash CB and m dash CD. Now come to the second iteration, same equation, rotational factor of BA into MFB plus far end moment minus 0.25 minus 48.8 plus, so it was 0 earlier. Now you have a value 19.6. The rotational factor of BC, MFB plus far end moment minus 0.25 minus 48.8. Again that will be the same far end moment 19.6. The m dash BC will be 17.12. See here, m dash BC 17.12 is the far end for joint C. M dash BC is the far end for CB, joint C. Now, yeah, here m dash CB is equal to rotation factor of CB, MFC plus far end moment. So m dash CB is equal to minus 0.333 is the rotation factor into 46.66 plus m dash BC is the far end value for joint C, 17.12. So it is 21.23, 10.65. So similarly, so third iteration, fourth iteration, fifth iteration. So m dash BA, m dash BC, m dash CB and m dash CB. See here, fourth iteration and fifth iterations. Fourth and fifth iterations, the value will be the same, nearly same. Then final moments, MAB is equal to MFAB plus 2 into near end contribution and here far end contribution, m dash BA. So MAB is equal to minus 35.55 is the fixed end moment for AB plus m dash AB is 0 and m dash BA is 17.55. That's the fifth iteration. So value is minus 18. And similarly, MBA is equal to MFBA plus 2m dash BA plus m dash AB. So BA is the near end and AB is the far end. 17.77 plus 2 into 17.55 plus 0. The value is plus 52.87. And similarly, MBC, MFBC plus 2 m dash BC plus m dash CB. So put the values what in the fifth iteration. So you will get all the bending moments, all the moments. So draw the bending moment diagram. See here at the A. So check whether the standard directions are matched with the signs of your final end moments or not. So what do you understand by standard moments, standard directions? So we have a standard direction for AB, BA, BC, CB, CD and DC. So the clockwise direction, first one is anti-clockwise direction, clockwise, anti-clockwise, clockwise, anti-clockwise, clockwise. Already you have studied in slope deflection as well as in the moment distribution method. First one is anti-clockwise, clockwise, anti-clockwise, clockwise, anti-clockwise, clockwise. So first one is anti-clockwise, so the value is minus 18. Take the height of 18 here. The next come to the BA 52.96, then 41.4. So join all the points, end points. Join 18, 52.96, 41.4 and 9.3 as per what you have calculated. The next, so draw the bending moment diagram for bending moment diagram for the load cases. So here there will be a point load WAB by L. So WL square by 8, so you will get 100, and WL by 4, so you will get 40. So this is your bending moment diagram. So first you have to check, so you have to draw 18, then from the B 52.96, 41.4 and 9.3. Join the lines. Then draw the bending moment diagram as per the loads. So WAB by L, it will be a triangle. So second B to C parabolic, and third C to D is a triangle. Next, shear force calculation. So here we have calculated the reaction at A, reaction at B, reaction at C and reaction at D. So we are considering the summation of moment at B equal to 0. So RAB into 3 minus 80 into 2 minus 18 plus 52.96. These are the end moments what we have calculated earlier. So RAB is equal to 41.68. Already I have studied in moment distribution as well as in the slope deflection method. So there is so how to calculate the reaction. So next, RAB plus RBA, so it will be 80, so you will get 32.32. For the span BC, again the summation of moment at B equal to 0, left hand side, RCB into 4, 50 into 4 into 4 by 2 plus MCB plus MBC. So RCB is equal to RCB 97.11. Then similarly you have to calculate RA, RB, RC and RD. So how to shear force diagram? How to draw the shear force diagram? See here, from the A, so you have to consider the RA, put the height of RA 41.68, take a straight line. When you have a point load, so it will be a straight line. When you have UDL, so that will be a triangular shape. So take the height of 41.68, take the straight line up to where the load you have. So take the line here 41.68. So what is the total load here? Total load is 80. 80 minus 41.68. So the height will be 38.32. C here 38.32 up to B. The next, so rise. What is the RB value? RB is 141.21 minus of 38.232. So you will get 102.89. So if you say UDL, it will be a triangle shape like this. So 102.89. What is the total load here? 200. 50 into 4, it will be 200. 102.89 minus of 200, you will get 97.11 negative. Then RC value. What is the RC here? 125.11. So here up to here there will be 97.11 plus 28, you will get 125.11 RC. The height of here 97.11 to 28. What is the height? 125.11. Take the straight line, come to the down. So what is the load? 40. So already you have a 28, then 12. Take a straight line. So it will complete at the shear force diagram. Thank you one and all. So MCQs are already in the website. So you can take the multiple choice questions. If you have any queries, so you can contact the authorities. So please go through the MCQs, multiple choice questions. So solve those. Those are 30 questions. So you have to solve that. So thank you one and all.